If you come across this question in your incoming CHM107 exam, how are you going to solve them? They are very easy. Now welcome back to this channel. In this video, I'll be solving 40 repeated CHM107 questions from previous sets as well as from past questions. Okay, now let's start with the very first question. Okay, question 1. Calcium carbonate undergoes thermal decomposition at high temperature to form calcium oxide plus and carbon dioxide or carbon dioxide. What mass of calcium oxide is formed when 60 grams of calcium tricarbonate 4 or calcium carbonate is completely decomposed? Okay, yes. So in this question, what are they asking us to look for? They're asking us to look for the mass of calcium oxide when CHO3 decompose. It's very easy. Okay, so just go to solve this type of question. This question is coming out from mole to mole relationship or mass to mass relationship. So there are different methods of solving this question. I will show you guys the two different methods you can use to solve this question. Now let's use the first method, mole to mole relationship, to solve this question. In this method, we release the moles of the reactant as well as the product. Now let's go to this part. Now remember, calcium carbonate decompose when heated into what? Into calcium oxide plus carbon dioxide or carbon dioxide, right? Yes. Now if you look at this equation is balanced. Okay, yes. Now I tell you guys I'll be using two methods, right? The first method I'll be using is mole to mole relationship. Now if you look at this, if you look at the question, remember this is the reactant, while this is the product, right? Okay, product, this is the product, this is the reactant. Okay, now if you look at the question, the relationship, if you look at the question, said, okay, what mass of calcium oxide is formed when 60 grams of calcium carbonate is completely decomposed? So therefore, the relationship is between what? Calcium carbonate and what? Calcium oxide. So forget about carbon dioxide. Okay, so the relationship is between these two. Now if we are to use the very first method, mole to mole relationship, we relate the moles of the reactant and the product. Okay, now if you look how many moles of calcium carbonate is here, if you look at it, it's just 1 mole. So do it like this, you say 1 mole of 1 mole of calcium carbonate we produce how many mole of calcium oxide? We still produce 1 mole of calcium oxide, right? Yes. So therefore we know that 1 mole of calcium from the balance equation. We know that 1 mole of calcium carbonate produce what? 1 mole of calcium oxide, right? Yes, we neglect carbon dioxide because in the question the relationship is just between calcium carbonate and calcium oxide. And from the balance equation, we found out that how many moles of calcium carbonate is in this balance equation? It's just 1 mole. What about calcium oxide? It's just still 1 mole, right? Yes. So therefore we say, okay, 1 mole. If we are using mole to mole relationship, we relate the moles of the reactant with the moles of what? The product. Okay. Now you find out that 1 mole of calcium oxide, of calcium carbonate produces what? 1 mole of calcium oxide, right? Yes. Now we'll go back to the question. They said calcium carbonate undergoes thermal decomposition at high temperature to form calcium oxide and carbon dioxide. Okay. Yeah, they said what mass of calcium oxide is formed when 60 grams of calcium carbonate is decomposed? Okay. Yes. Am I going to do like this? Am I going to do something like this? Okay, because we are looking for what? We are looking for the mass of calcium oxide that is formed, right? Yes. Am I going to do like this? Where is okay? 60 grams of CHO3 we give S gram of calcium oxide. No. Remember, this method is mole to mole relationship. So therefore, since we are using mole, since we are using mole to solve, we need to convert this 60 grams to mole. Okay, because we are using mole. This type of relationship is relationship between the moles of reactants and the moles of product, right? So we are going to use moles. Okay, so we need to convert this 60 grams to mole. How we going to convert 60 gram to mole? It's very easy. Remember, number of mole is equals to what? Giving mass over what? Molar mass, right? Yes. Now, what is giving mass of calcium carbonate? Giving mass of calcium carbonate is 60 gram, right? Yes. So the giving mass of calcium carbonate is what? Is 60 gram, right? Yes. What about the molar mass of calcium carbonate? If you look at this place, the molar mass of calcium carbonate is what? Is 100 gram, right? So if we divide it, let's do it. If we divide it, 60 divided 100, 60 divided 100, that will give us the number of which is what? 0.6, right? Yes. So therefore we are successfully converted from what? From 60 gram to mole. Remember, we are using mole to solve, not gram, right? So therefore we now do something like this. We now say 0.6 mole of calco-3 we give what? An S mole of what? An S mole of calcium oxide. Okay? Yes. Please remember that under mole to mole relationship, we relate the moles of the reactant to the mole of the product. The very first thing we are going to do, we relate the moles from the balance equation. From the balance equation, we find out that 1 mole of calcium carbonate produces what? 1 mole of calcium oxide, right? Yes. Then from the question, we find out that 60 gram, or they said what mass of calcium oxide is formed when 60 gram of calcium carbonate is completely decomposed. Okay, so we need to convert this 60 gram to what? To mole, so that we can use it to solve. Okay, because we are using mole to mole relationship. Okay, so we converted 60 gram to what? To mole, which is 0.6. Using what? Number of mole is equals to giving mass over molar mass, right? The giving mass is what? Is 60. The molar mass of calcium carbonate is what? Is 100. So if we divide, we get the mole. Okay, so what next are we going to do? We just need to cross multiply. 1 will multiply 0.6, 1 will multiply S. So 1 times 0, we have something like this. 0.6 times 1 equals to what? 1 times S, right? Yes. Okay, 0.6 times 1 will still give us 0.6, right? Then 1 times S will give us S. Therefore, the mole of calcium oxide form is what? Is 0.6. Okay, I'm coming. The mole of calcium oxide form is what? Is 0.6 mole. Okay, yes. Are we done yet? No. What are we looking for? They said what mass of calcium oxide is formed. Okay, remember under mole to mole relationship, we will first of all relate the moles of the balance equation first. Then if you look at the question was the mass of they gave us the mass of calco-3. They gave us the mass of calco-3. So we converted this mass to what? To mole, so that we can get the mole of calcium oxide, right? The mole of calcium oxide is what? The mole of calcium oxide that we get is 0.6 moles. Okay, and what are we looking for? We are looking for what? Let's say what mass of calcium oxide is formed, but we are not. So, but we have not the mole of calcium oxide to what? To 0.6 mole. So what are we going to do next? Using this formula, N is equals to giving mass over what? Over molar mass, right? The mole of calcium oxide is what? 0.6. Then equals to giving mass. That's what we are looking. That's what we are looking for, right? So what mass of calcium oxide is formed? We don't know. Then divided by the molar mass of calcium oxide. The molar mass of calcium oxide is 56. Okay. So if we cross multiply, S will be equals to what? 0.6 times 56. Okay. So 0.6 times 56 will give us 33.6. Therefore, the answer is what? Is 33.6. Okay, which is D. Please, these are past questions. Okay, so these are hard to solve. These are to solve questions relating to this type. These are to solve questions like this. Okay, remember I told you guys two methods. I said we use mole to mole relationship or use mass to mass relationship. Now let's use mass to mass relationship. Okay, now we all know that from the balance equation, calcium carbonate decompose into what? Calcium oxide and what? And carbon oxide, right? Yes. Remember the relationship is between what? Is between calcium carbonate and calcium oxide, right? Yes. Now, since we are using Remember, in the previous method I showed you guys, we use mole to mole, right? Yes. Now, in this method, we just use mass to mass, okay? Yes, how are we going to do it? Now, if from the balance equation, this one is very fast, okay? Now, from the balance equation, how many mole of calcium carbonate is here? How many mole from the because this question is balanced, right? So how many mole of calcium carbonate is in this equation? It's just one, right? Yes. So number of mole is one, right? Yes. Then the molar mass of calcium carbonate is what? If you look at the molar mass of calcium carbonate is what? Is 100, right? Yes. Therefore, we use these two. Remember, number of moles is equals to what? Giving mass to our molar mass, right? Yes. And from this balance equation, how many moles do calcium carbonate have? Is one, right? The mass we don't know. The molar mass is what? 100, right? If we cross multiply, S will give us equals to what? 100. 1 times 100 give us 100, right? Yes. Therefore, the mass of calcium carbonate here is what? Is 100 gram. Okay, so we'll do something like this. In mass to mass relationship, we relate the mass of the reactant to the mass of the product. We'll do something like this. We'll say 100 gram of 100 gram of calcotiri. I'm coming. 100 gram of calcotiri we give what? Now, how many mole of calcium oxide is here? It's just still one, right? Remember, number of moles is equals to mass over our molar mass, right? Yes, how many mole do calcium oxide have here is one, right? Then equals to what is the mass? We don't know the mass, right? We put S, then divided by the molar mass of calcium oxide is what? Is 56. Okay, so we have 56. If we cross multiply, the mass of calcium oxide will be what? 56, right? So you do something like this. You say 100 gram of calcium carbonate will give what? 56 gram of calcium oxide, right? Yes. Then we'll go to the question. Remember, in the question they said, what mass of calcium oxide is formed when 60 gram of calcium carbonate is completely decomposed? So how many gram of calcium carbonate is completely decomposed? 60 gram. So you go there, you say 60 gram of calcium carbonate will give what? An S gram of calcium oxide, right? Yes. This method is kind of fast, okay? So we just cross multiply. 56 will multiply 60, 100 will multiply S. So 100 times S we give then 56 times 60. Okay, so if we continue, 100 times S is 100S, right? Then 56 times 60 is what? Is 3,360, right? Yes, we are looking for S, so divide both sides by 100. Okay, now if we divide both sides by 100, 3,360 divided 100 will give us 33.6 gram. Therefore, the answer is what? D. Okay, yes. So there are two methods you can use. You can use mole to mole relationship, whereby you use the moles of mole to mole relationship. Okay, yes, I've told you guys there are two methods you can use to solve this type of question. Okay, yes. If you use mole to mole relationship, you will first start from the balance equation. From the equation, find out that 1 mole of what? 1 mole of calcotiri give how many mole of calcium oxide? 1 mole of what? Calcium oxide, right? Yes. Then you go to the question. They say what mass of calcium oxide is formed when 60 gram of calcotiri is decomposed? You convert this 60 gram to what? To mole. If you convert the 60 gram to mole, I think you have you convert it to mole by dividing the mass by the molar mass. 60 divided 100, we have 0.6. So if you convert the 60 gram to mole, we have 0.6 mole. We now be something like 0.6 moles of calcotiri. We now give what? An S mole of calcium oxide, right? Yes. So if we cross multiply, we find out that the mole of calcium oxide formed is what? 0.6. Then since you got the mole, you convert this mole back to mass, because they say what mass of calcium oxide. That is because we are looking at the mass of calcium oxide. We have already got the mole of calcium oxide to be 0.6. So once you got the mole, then the mass divided by molar mass. The molar mass of calcium oxide is what? Is 56. If you cross multiply, you get the mass. Okay, but the other method, which is the mass relationship, That one is kind of faster, okay? In mass relationship, you still use, if in mass relationship, remember relationship is between what? Calcium carbonate and calcium oxide, right? Yes. Now from in mass relationship, we use mass. We use mass to solve, not mole. Okay. From the balance equation, we find out that calcium oxide is what? I mean, calcium carbonate has how many mole from the balance equation? It's just one mole, right? Remember, number of moles equals to giving mass over molar mass, right? We go to this place, number of moles equals to giving mass over molar mass, right? Calcium oxide, that calcium carbonate has how many mole here? It has one mole. The molar mass is what? Molar mass of calcium carbonate is 100. If you cross multiply, we find out that the mass of from this balance equation of calcium carbonate is what? Is 100, right? So we do something like we do something like this: 100 gram of calcium carbonate to give what? Remember, from the balance equation, calcium oxide has how many mole? 1. We don't know the mass. The molar mass of calcium oxide is 56. If you cross multiply, I find out that the mass of calcium oxide will be what? Will be 56 gram, right? So you do something like this. You say 100 gram of calcium carbonate will give what? 56 gram of calcium oxide, right? Then you go back to the question. Say one mass of calcium oxide is formed when 60 gram of calcium carbonate is decomposed. You do something like you do something like you say 60. You do something like you say 60 gram of calcium carbonate will give what? An S gram of calcium oxide, because where we are looking for the mass of calcium oxide. So what next? To cross multiply 100 times S will give us 100S. Then 56 times 60 will give us 3,360, right? Divide both sides by 100, you get what? Get your mass, which is 33.6 gram. So these are to solve questions relating to this. You can either use two methods: mole to mole relationship or what? Mass to mass relationship. Okay, mass to mass relationship is kind of faster. Okay, so we move to the next question. Question 2. They said calculate the molarity of concentrated hydrochloric acid if this solution is 33% hydrochloric acid by mass. Okay, they said calculate the molarity of concentrated hydrochloric acid if this solution is 33.7% hydrochloric acid by mass and its density is what? 1.195 gram, okay, per gram per mil, okay, gram per milliliter, okay. Yes. Now what are they asking us to look for? They're asking us to look for what? The molarity of concentrated hydrochloric acid. Now how are we going to solve? Which formula are we going to use to calculate molarity? And molarity is very easy. Molarity. What is molarity? Molarity, which is capital letter M, or you can use C, is what is number of moles of the. Remember, a solution. A solution is made up of what? So a solution is made up of a solute and what? And a solvent, right? Yes. So the molarity of a solution is the number of mole of what? Is the molarity of the solution is number of mole of the solute in that solution divided by the volume of the solution in what? In liter. Okay. So this is the formula to calculate for molarity of a solution. Okay. The molarity of the solution is equal to what? The number of mole of the solute divided by the volume of the whole solution in liter. The volume must be in what? In liter. Okay, now let's go back to the question. They said calculate the molarity of concentrated HCl if this solution is 37.7% hydrochloric acid by mass and its density is what? 1.195 gram per mil. Okay, now if you look at this question, they didn't give us volume directly. They didn't give us number of mole directly. So we have to look for them using the parameters they give to us. Now they gave us density. Density to be what? 1.195 gram per mil. Okay. Now if you remember from your physics, we know that density of a substance is equal to the mass of that substance over what? The volume, right? Yes, which is very important. Because we want to look for volume, okay? We want to look for volume, we want to look for number of mole. Once you get these two, divide this, you get what? The molarity. Okay, so remember that density is equal to mass over volume, right? Yes. Now from the question, you find out that the density of HCl is what? The density of HCl is what? 1.195 gram per mil, right? Yes. So this means that, let me tell you something. Now this 1.195 gram per mil, it means that 1.195 gram is dividing what? Is dividing 1 mil. I don't know if you understand. Okay, so that is what this means. Okay, it means that 1.15 gram is dividing with 1 mil. If 1.195 gram divide 1 mil, we will get what? You still get this back. If 1.195 gram divide 1 mil, you will still get what? You will get 1.195 gram per mil back. It's just the same thing, okay? Anything divided 1 will give you that same thing, right? Yes. So from the question, the density is what? The density is what? Of hydrochloric acid is what? 1.195 gram per mil, right? Yes. Which is the same thing as, which is the same thing as what? 1.195 gram dividing what? 1 mil, right? Yes. Now if we continue, remember I told you guys that volume in molarity, our volume is always in what? In liter. Okay, our volume is always in liter. Therefore, this milliliter, we need to convert it to liter, right? Yes. So 1.195 gram dividing what? Dividing 1 milliliter. Okay. Now, don't forget that a milliliter is what? Milli is what? Milli is 10 times, is 10 raised power minus 3. I don't even understand. Milli is what? Is 10 raised power minus 3. Okay. Then per liter there. I don't even understand. Milli means 10 raised power what? Minus 3. I don't even understand. So we have successfully converted from mil to what? To just liter, right? Yes. So okay, so let's continue. Okay, so the density is what? 1.95 gram dividing 1. We all know that the density is what? 1.195 gram dividing per mil, right? Yes. And I told you guys that it's the same thing as what? 1.195 gram dividing what? 1 mil, right? Yes. Now what next? I told you guys that we cannot use mil to solve, right? 1 mil, we cannot use we don't use mil to solve in molarity. We use liter. So we convert it to what? We convert it to what? To liter. 1 milliliter is something as what? Is something as what? 1000 raised power minus 3. I mean, okay, it's something as what? 1 milliliter is something as what? 10 raised power minus 3 liter. Okay. Yes. Okay, let me use. Okay. So 1 milliliter is something as what? 10 raised to power minus 3 liter. So therefore, we'll put what? 10 raised to power minus 3 liter here. I don't even understand. That's successfully converted what? 1 milliliter to what? To liter. Right? Yes. So don't forget that the density is now what? The density is now what? 1.195 gram dividing what? 10 raised to power minus 3 liter, right? Yes. Are we done yet? No. Okay. So if we divide, okay. So if we divide everything, let's divide everything. Okay. Now let's divide everything. If we divide everything, 1.195 divide 10 raised to power minus 3. We will have what? We will have 1195. I don't understand. Okay. Now to simplify everything, let me go to this place. I'm coming. Now let me to simplify everything for you guys. The density is what? We are going to this part. The density is what? 1.195 gram, right? Dividing what? 10 raised to power minus 3 liter, right? Yes. Now, according to indices, right? According to indices, 10 raised to power minus 3 is the same thing as what? It's the same thing as 1 divided 10 raised to power 3, right? Yes. According to indices. According to indices, when a number is raised to power of a negative value, it means 1 divide that number raised to power the value. I don't even understand. Therefore, 10 raised to power minus 3 is something as what? 1 divide 10 raised to power 3. I don't even understand. Okay, so therefore, since 10 raised to power 2, since we arrive it at this point, right? 10 raised to power minus 3, which should be the same thing as what? Which should be the same thing as 1 divided 10 raised power 3 liter, right? Yes, according to mass, this side will come over up, will come upward, right? This 10 raised power 3 will come up, right? So now something like this, D is equals to what? 1.195 times 10 raised power 3 divided what? 1 liter. Okay, yes, so don't get yourself confused. Okay, so if we multiply this, we have what? We have 1195 divided what? 1195 gram divided 1 liter. Okay, so therefore our density is what? Our density, from, if we combine everything, our density is now what? Our density is now what? 1195 gram dividing what? 1 liter. Okay, yes. So let's tell you that, remember, density is mass over volume, right? So let's tell you that our mass is what? Our mass is 1195, then our volume is what? Is 1 liter, right? Yes, don't forget, we are reading from molarity. Molarity is equals to number of mole over volume, right? So our volume is now what? Our volume is what? Our volume is 1 liter already, right? Yes. Now the mass is what? The mass is 1195, right? Yes, 1195 gram. So now let's continue. Our volume is on 1 liter, right? Yes, our volume is 1 liter. Then the mass is what? The mass is 1195 gram. Okay, yes. Now, they being that this question is a straightforward question, we would have just do something like this. We all know the number of mole is what? Is equals to the mass in gram over what? The molar mass, right? The mass in gram is what? 1195. Then the molar mass of hydrochloric acid is what? 36.5, right? We would have divided it. We would have divided it, then put it here. We would have put it here, divide it to 1, we get our molarity, right? Yes, that is how it's supposed to be. But if you look at the question, they said, calculate the molarity of concentrated HCl if this solution is 37.7% hydrochloric acid by mass. Okay, yes. So that is tell you that there are 37.7% hydrochloric acid in the solution by mass. Okay, so this question is a straightforward question, right? The mass of the whole solution is what? Is 1195, right? Yes, they said, okay, calculate the molarity of concentrated HCl if this solution is 37.7% hydrochloric acid by mass. Now, 37.7% hydrochloric acid by mass. It means that 37.7 gram of hydrochloric acid is dividing what? Is dividing 100, right? Yes, 37.7% by mass of hydrochloric acid means that 37.7 gram of hydrochloric acid is dividing what? 100, right? Then don't forget, the mass of the whole solution is what? The mass of the whole solution is what? Is 1195, right? So times 1195. Okay, so if we do everything, we get what? We get 37.7, then times 1195, then divide 100. Divide 100, we get what? We have the mass of hydrochloric acid. Remember, they said the mass of hydrochloric acid in the whole solution is what? Is 37.7% by mass, right? That means that 37.7 gram of hydrochloric acid divided by 100 times the whole mass of the solution. I don't understand. Now, let me break it down. Remember, the whole solution, the mass of the whole solution is 1195, right? Yes, out of this whole mass, the percentage by mass of hydrochloric acid inside let's the whole mass of this solution is 1195, right? Yes. Now, out of 100%, 37.7% of the mass of this solution is what? Is hydrochloric acid. So that's why I do like this. 37.7% hydrochloric acid by mass, right? So they say if this solution is 37.7% hydrochloric acid by mass, it means that we all know that the solution is what? Is 100%, right? Yes, it's 100%. So it's 100%. So out of this 100%, 37% by mass is what? Is hydrochloric acid, right? Now, don't forget that the mass of the solution is what? 1195. Let me understand. the whole solution, a full solution is 100%, right? Yes, 100% by mass. Now, out of this 100%, 37.7% by mass is what? Hydrochloric acid. Don't forget that the mass of the whole solution is what? Is 1,195. So times 37.7%. Now remember, 37.7% means what? It means 37.7 is dividing what? 100. Can you understand? So if we do everything, the mass of carbon of hydrochloric acid in the whole solution will be what? Is 450.515 gram. Okay, yes. So out of the entire mass, which is 1195 gram of the whole solution, out of the entire mass of this whole solution, 450.515 gram is what? Is the mass of what? Is hydrochloric acid. Okay, so that is what this 37.7% that mass mean. Okay, so out of the 1195 gram of hydrochloric acid in okay, so after this mass, 450.51 gram is hydrochloric acid. The rest is water. Okay, so let's condensate, calculate the molarity. We have gotten the mass of hydrochloric acid in this solution to be what? 450.515, right? Yes. Okay, so the mass is what? 450.515, right? So let's continue. Now remember, number of mole is what? Number of mole is the mass in gram of our molar mass, right? Yeah, what is the mass in gram of hydrochloric acid? Mass in gram of hydrochloric acid is what? Is 450, right? Yes, 0.515, right? Okay, you can neglect that one. Divided by the molar mass of hydrochloric acid. Remember, this is hydrochloric acid, right? The molar mass of hydrochloric acid. What is the mass of hydrogen? 1. Then what is the mass of chlorine is what? 35.5. So if we add everything will be what? 36.5 gram per mole, right? So this is the molar mass. Okay, so this is the molar mass of what? Of the molar mass of hydrochloric acid is what? Is 36.5. Okay, so if we divide it, 450 want to get the mole. Once you get the mole, put it here. We divide it by the volume, which is 1 liter, right? Yes. So 450.515 divided by 36.5, to give us what? 12.34. Okay, so the number of mole is what? Is 12.34, right? Yeah. So if you put it here, number of mole is what? 12.34. The volume is what? 1, right? So if you do it, 12.34 divided 1 liter or anyone, divide 1 will still give us 12.34 molarity. So the molarity is what? 12.34, which is B. Okay, 12.3. Okay, so that is how to solve it. Okay, so let me just summarize how to solve it again. Okay, if you look at the question, they say we should calculate for what? The molarity. They say we should calculate for what? The molarity of concentrated hydrochloric acid, right? Yes. Now remember, molarity is what? The number of mole of the solute in a solution divided by the volume of the solution in what? In liter, right? Yes. Now in the question, they didn't give us in mass. They give us number of mole of the solute, which is hydrochloric acid. They didn't give us the volume of the solution, right? Yes. They only gave us the density of the solution to be what? They give us the density of the solution to be what? 1.195 gram per mil, right? Yes. And we all know that density is on mass over volume, right? Yes. So from this density, we get our volume, we get our mass, and we get our volume, right? And I told you guys that 1.95 gram per mil. It means 1.195 gram is dividing what? 1 mil, right? Yes. And 1 mil is, remember, we don't use mil, we use liter, right? 1 milliliter is something as what? Is 10 raised to the minus 3 liter, right? Yes. Remember, in mass, 10 raised to the minus 3 is something as what? 1 divided 10 raised to the 3, right? So now everything will be what? 1 liter, 1 divided 10 raised to the 3, right? Now according to mass, this one will come up, right? So now be what? So now be 10 raised to the 3 multiplying this, right? So if 10 raised to the 3 multiply this, we have what? 1195 then gram dividing what? 1 liter. So therefore, the mass of the solution is 1195 in gram. Then the volume of the solution is what? Is 1. Okay, our volume is 1, right? 1 liter. Then the mass of the solution is what? Is 1195, right? Yes. Now if you go for continue, they said 37.7% by mass. They said okay, out of this mass of this is the mass of your solution. Okay, 100% of the now 37.7% of this mass is hydrochloric acid. Okay, so 37.7% means that this whole means that 37.7 gram divided 100 we multiply times the 1195. We get what? We get the mass of hydrochloric acid in the solution, which is what? Which is I think the mass is what? 450.515, right? Yes, we've gotten the gram of hydrochloric acid in solution to be 450.1515. Then we use this mass to look for the number of mole of hydrochloric acid using n equals to number of mole divided n equals to given mass over what? Or n equals to mass gram over molar mass, right? We use it to look for the number of mole of hydrochloric acid. We got what? 12.34 to be the number of mole, right? So you divide it by 1, you get what? Your molarity. Okay, so this number 1, 2 question is just one of the questions that is very tricky. Okay, yes. Now the rest questions, they are easy and not that tricky. Now let's move to the next question, which is question 3. So question 3 is what? Question 3 is molarity as well. Let me tell you that in your CHM107 exam, most of the questions. So this will tell you that most of your questions are coming from, the more questions you do, you find out that most of them are coming from molarity, stoichiometry, acid, base, and salt. And okay, let's move to the third question, which is how many? They said this question is straightforward. They said how many grams of potassium chloride would be required to produce 0.02 molar solution of the salt. Okay. So this is molarity. Okay, don't forget that molarity of a solution is equals to what? The number of mole of the solute. Remember, a solution is made up of what? Solution is made up of a solute and plus what? The solvent, right? Yes. So the number of mole of the solute divided by the volume of the solution in what? In liter. This is very important. Okay. Yes. Now look at the question. They say how many grams of calcium chloride would be required to prepare 0.02 molar solution? 0.02 molar solution means is what? Is the molarity. Okay, 0.02 molar solution is molarity. That is, they are telling us that molarity is what? Is 0.02. Okay, yes, molarity is 0.02. What are they telling us to look for? They're telling us to look for the gram of calcium chloride, which is the solute. Okay, yes. Now what are we going to do? We use normally they give us the value. They give us the volume. They give us the volume indirectly. Okay, we have to look for what? We have to look for the mass. We have to look for the mass of what? Of calcium or potassium chloride, right? Yes. Now how are we going to get the mass? Normally we need to first get our what? The number of mole of the solute or the number of mole of calcium chloride. Once we get number of mole of calcium chloride, we all know that number of mole is equals to what? Mass in gram, right? Over the molar mass, right? Yes. So once we get number of mole, we use number of mole and the molar mass of calcium chloride to look for the what? To look for the mass in gram of what? Of potassium chloride. I don't even understand. Okay, so that's what they are telling us to do. They are telling us to look at the mass of potassium chloride, right? How are we going to get the mass of the solute, which is potassium chloride? We need to find out the number of mole of the solute, of which we don't know. If we get number of mole, then from number of mole, we know that number of mole is equal to mass in gram over the molar mass, right? Let's say the number of mole is 2, for example. We are looking for the mass in gram, right? We look at molar mass of potassium chloride, then we cross multiply, we get our mass in gram. Okay, so or we get our given mass. Okay, so let's look for the mole of the solute first. Okay, now the molarity of the solution was 0.02, right? Yes. Now if you look at this question is still tricky, but not that. They say how many grams of potassium chloride would be required to prepare 0.02 molar solution of the salt, right? Now the molarity was 0.02. Now the molarity was 0.02 mole per don't forget Molarity is 1 mole per volume, right? So what is the SI unit for mole? SI unit of mole is mole. What is the SI unit of volume? Is liter, right? So the molarity that they gave us, they said the solution contained 0.02 mole per liter of they said, okay, how many grams of potassium chloride would be required to prepare 0.02 molar solution of the salt? So the molarity of the salt is what? 0.02 mole per liter, right? Yes. Now, if you look at it very well, 0.02 mole per liter, 0.02 mole per liter it still means that 0.02 mole is dividing what? 1 liter. I understand. So if 0.02 mole divide 1 liter, we get what? We get 0.02 mole per liter. I don't understand. So this one means the same. It means that 0.02 mole is dividing what? 1 liter, right? Yes. So that's to tell us that. So that's to tell you that the number of mole is what? 0.02 mole, while the volume is 1, right? Yes. Remember, we're looking for what? We're looking for the gram of the salt, right? So therefore, we have known our number of mole to be 0.02. Therefore, number of mole is equals to the mass in gram divided by the molar mass, right? The number of mole of the they say, okay, yeah, of the salt is what? Is 0.02, right? Yes. Then they give mass. I mean the mass in gram or the given mass. Okay, the mass in gram, that's what we are looking for, right? S. Then divided by the molar mass of calcium chloride. So how do we get the molar mass of calcium chloride? Calcium chloride. Okay, this is calcium chloride, right? This is calcium chloride. Calcium chloride. Now, where is the mass? Where is the molar mass of calcium? Molar mass of, what am I saying? Potassium chloride, okay? So where is the molar mass of potassium chloride? Molar mass of potassium chloride is 39. Then where the molar mass of potassium is 39. Whereby chlorine, molar mass of chlorine is what? 35.5, okay? So if we add everything, we have what? 39 plus 35.5 to give us 74.5. Therefore, the molar mass of potassium chloride is what? 74.5. Okay, so the molar mass is what? 74.5. Okay, we're looking for the mass in grams. So if we cross multiply, 0.02 times 74.5 will give us what? Give us the given mass, right? Yes. So let's do it. So if we do it, 0.02 times 74.5 give us 1.49. Okay. Oh my, okay, yeah, 1.49, which is what? Which is A. So that is the answer. Okay. So now let's move to the next series of questions, which is question 4, question 5, question 6, question 7. Now let's continue with the next question, which is question 4. They said the following are suitable primary standard except, okay, so please, these are repeated questions from previous years as well as previous sets. Okay, so they said the following are suitable primary standard except. So now what are suitable primary standard? These substances are usually pure, they are not deliquescent, they are not hygroscopic, and usually have definite composition. Okay, yes. So all of these substances, they are what? They are suitable primary standard, such as sodium carbonate, potassium heptase dichromate 6, sodium chloride. Okay, yes. These substances, they are not deliquescent, they are not hygroscopic, they they are pure, and they have definite composition. Therefore, the answer here is sodium hydroxide. Okay, yes, sodium hydroxide is not used as is not a suitable primary standard. Okay, yes, so sodium hydroxide, because sodium hydroxide is deliquescent. Okay, so that is why it's not a primary it's not a suitable primary standard. Okay, now let's move to the next question, which is question 5. They said, what is the concentration in mole per dm cube of a solution of sodium hydroxide that contains 16 grams of sodium hydroxide in 200 cm cube? Okay, so this question is known as what? It's known as molarity, right? Molarity is known as concentration, or you can say concentration is also known as molarity. Don't forget, molarity is what? Is number of mole of the solute. In this case, the solute is what? Is sodium hydroxide, right? Yes, number of mole of the solute divided by what? The volume, and the volume must always be in what? In liter. Okay. So I'm looking for what? We're looking for the molarity. Molarity is known as concentration, right? Yes. So don't forget that liter and dm cube. 1 liter is still something as 1 dm cube. Okay, yes. Then 1 cm cube is something as 1 uh, mil. Okay, yes, 1 mil. 1 cm cube is something as 1 mil. Okay, yes. Okay, so let's continue. So now we are looking for what? The molarity, right? Yes. Now let's look for we're looking for the molarity. Okay, they gave us the gram of the solute, which is sodium hydroxide. They gave us the gram. They gave us the volume of the solution. So we have to use this gram to look for a number of moles of sodium hydroxide. Then we divided by what? The volume. Now the volume must always be in what? In liter, right? So convert this volume to what? To liter. So that is just it. So don't forget, let's have a number of moles. The number of moles equals to what? Mass in gram, right? Divided by the molar mass. So what is the mass in gram of sodium hydroxide? Is what? 16. Then what is the molar mass? The molar mass of sodium hydroxide. Sodium hydroxide. Okay. Sodium is what? 23. So oxygen is 16. Hydrogen is 1. So if we add everything, we have the molar mass is 40. Okay. So the molar mass is 40. So 16 divide 40, we get 16 divide 40, we give us 0.4. Therefore, the mole is what? The mole of the solute is 0.4. then what about the volume of the solution? The volume is what? The volume is 200, right? Yes, 200 centimeter cube, right? Yes. Remember, our volume is will always be in liter or dm cube. So what are we going to do? We convert it to what? To the dm cube, to liter or dm cube by dividing by what? By dividing by what? 1000. If you divide it by 1000, this one will cancel this. So 2 divided 10 is 0. If you do 200 divided 1000 generally, 200 divided 1000 will give us 0.2. So therefore, our volume in liter is what? 0.2. Okay. Yes. So if we divide everything, what will be our answer? 0.4 divided 0.2 will give us 2. Okay. Give us 2. Okay, we give us 2. So therefore, the answer is what? 2, which is what? A. Okay. Then let's go to the next question. Question C. It's still form of this. So let me tell you that most of your questions are usually coming from molarity, acid base, especially molarity and acid base. This is very like molarity, concentration, acid base. That's where most of your questions are coming from. Okay, that is like regarding CHM107. Okay, then what is the concentration of the standard solution in mole per liter prepared by dissolving zero? It's still the same thing we just did just now. This one and the mass of sodium hydroxide is 0.4. The previous one is 16. So let's go number of moles. Number of moles is equal to given mass, right? Given mass is 0.4. Then the molar mass is what? We calculate the molar mass just now. Molar mass is 40, right? So 0.4 divided 40. 0.4 divided 40 will give us 0.01. So the number of moles is what? 0.01. Then what about the volume? If you look at the question, the volume, normally our volume must always be in liter, okay, or dm cube. So you look at the volume is what? Is in mil, 250 mil. So to convert 250 mil, to convert from mil to liter or dm cube, divide by what? 1000, okay? So we divide it by 1000, 250 divide, this 250 convert it to 250 mil, convert it to liter. So dividing by 1000, 250 divided 1000 give us what? 0.25. So here is what? 0.25, right? So if we do everything, we have what? 0.01 divided 0.25 will give us 0.04. Therefore, the molarity is what? 0.04. Molarity is something as concentration, okay? So the answer is what? B. Okay, now let's go to the next one, question 7. They said it's under pH, okay? It's under pH. Now, you can go check our previous video. I did a full video on how to calculate pH, pOH, buffer solution, and a lot of that. Okay. Now, pH is equals to different formulas. Okay. Negative log of hydrogen ion concentration. Okay. Yes. Now, if you look at this question, what is the hydrogen ion concentration of a solution whose pH is Which pH is 5.3? It's very easy. The pH is what? Is 5.3. Right? Then minus log base 10. We're looking for what? Hydrogen concentration, right? We don't know. So to look for the hydrogen concentration, multiply both sides by minus, right? If minus multiply this, minus multiply this side, minus multiply this, you cancel this, right? If minus times minus give you plus, right? So the minus cancel this side, right? Yes, so left with us minus 5.3 is equals to log 10, log base 10, then hydrogen ion, right? Yes, okay. So to look for hydrogen ion, to look for the hydrogen ion concentration, we need to take the anti-log. Anti-log will cancel this log. We need to take the anti-log of this value. I don't understand. Okay, the very first thing, remember, the very first thing you need to do at first, generally, we arrive at something like this, right? Yes. So to remove this negative sign, multiply both sides by what? Minus, right? If minus multiply 5.3, we have minus 5.3. If minus multiply this, minus times minus, we have plus, right? So we cancel the so there's plus here, right? The minus are remove, right? Yes, we now arrive something like this. Okay, now what I'm going to do next, we'll take the anti-log. Okay, to take anti-log, we take the anti-log of this value. Okay, yes, take the anti-log of this value. To take the anti-log of this value, we want to get h plus, right? So h plus, take the anti-log of h plus is equals to 10 raised power minus 5.3. Okay, you're looking for h plus, right? So to take the anti-log, just go to your calculator, then write 10, then raised to power, put the value minus 5.3 to give you an answer. Okay, so that is very easy. Go to your calculator, then if you go to your calculator, there are two ways. Write 10, then raised to power, then minus 5.3. Okay, so if you do it, we have 5.0 times 10 to the minus 6. So that is, the answer is A. Or if you want to do it, if you want to use the other method to do it, just go like this. Just say shift log, then that's minus 5.3. Okay, yes, you still get 5.01 times 10 to the minus 6. So the answer is what? Is 5 times 10 to the what? Minus 6, which is 8. So that's how to look for the hydrogen ion concentration. Is very easy. Okay, so to know more about it, go to our previous class video, you see it. Okay, under acid-base reaction. Okay, now let's go to the next question. Question 8. What is the likely pH? So this will tell you that most of your questions are usually coming from molar concentration, from molarity, then acid and base, like a lot. So what is likely pH of a solution which contain equivalent amount of hydrochloric acid and ammonia? Now, hydrochloric acid is a strong acid. Okay, it's a strong acid. It's a strong acid. The ammonia is what? Is a weak base. Is a weak base. Is a weak base. Okay. Now they're telling us that what is the pH of a solution that contains equal amount of hydrochloric acid and ammonia? A solution that contains equal amount of hydrochloric acid and ammonia is what? If we have a solution of these two, and normally they will usually react to form ammonium chloride. Okay. Usually react to form ammonium chloride. Okay. Yes. Ammonium chloride. This salt is formed from what? From hydrochloric acid and ammonia, right? And ammonia is what? A strong acid. I mean, hydrochloric acid is a strong acid. The ammonia is a weak base. So that's to tell you that this salt that is formed, which known as ammonium chloride, is a salt formed from what? From a strong acid and a weak base. So take note that salt formed from a strong acid and a weak base. Salt formed from a strong acid and a weak base is acidic. They are acidic salts. Okay, they are acidic. So that will tell you that. So that's the term. I remember in pH scale, we have 1, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? In pH scale, we all know that 7 is neutral, right? Then from 8 to 14 is what? Is alkaline, right? Then from 1 to 6 from 1 to 6 is what? Acidic, right? Yes, 1 is very acidity increase in this direction, alkalinity increase in this direction. So let's tell you that substance with 1 are very acidic. Okay, let's continue. So a solution that contains hydrochloric acid and ammonia is an acidic solution, right? Yes. So that's it, that the pH will range around this position here, because this position from 1 to 6 in a pH scale is what is acidic. Right from 8 to 14 is what is basic or alkaline, while 7 is neutral, neither acidic or non-basic. So let's say that our likely answer will be what will be A, which is 6. Okay, 7 means neutral, 8, 9 means alkaline. Okay, so the answer will likely be A, because 7 is neutral, 8 and 9 alkaline, right? Yes. So let's move to the next series of questions. Okay, so let's continue with the next few questions, which is question 9 to question 14. Okay, so in question 9 they said, which of the following compound is the most acidic? Okay, yes, A, 0.1 molar solution of okay, so 0.1 molar solution of H3PO4 acid. The pH of this acid is what? 4. Then B, 0.1 molar solution of this acid. The pH of this acid is 4.4. Okay. Then if we move to this side, 0.10 molar solution of this acid, of this substance, the pH is 9.3. Okay. Then D, 0.10 molar solution of this ion, the pH is 12. So they're asking us which of the following compound is the most acidic. Okay, remember I told you guys in pH scale from okay, let me just draw it. Okay, so let's say, or let's do this question first. Okay, then so that I can provide space for this. Now question 14, which of the following is a correct identification of oxygen gas? What is the test? What test are we use? What test we usually use for oxygen gas to test for oxygen gas? Remember, the test is that oxygen rekindles a glowing splint. So that is the test for oxygen. Oxygen rekindles a glowing splint. So the answer is what? B. Okay, very important. The correct identification of oxygen, or what is to identify oxygen gas, is a glowing splint. Okay, oxygen rekindles a glowing splint. So the answer is what? Is B. Okay, so now let's move back to question 9. Okay, so remember I told you guys that in pH scale, pH scale start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, then 14. Okay, so you guys that 7 is usually neutral. Okay, substance that has a pH of 7, they are neither acid nor base. Okay, yes, from here to this side means increase acidity. Okay, while from here to here is what? Increase alkalinity. Increase alkalinity. So let's just tell you that if from here to here means increase in acidity, let's say that substances that have pH of 1, they are the most acidic, they are very, very acidic. Then this one, they are less acidic than this. This one lesser than this one, less. So let's tell you that substances that have pH of 6, they are not that acidic compared to substances that have pH of 5. Substances that have pH of 5 is not acidic, it's not as acidic as substances that have pH of 4. So let's tell you that substances that have pH of 1 they are very, very, very acidic. Then if you go to this side, increase alkalinity, right? So that will tell you that substance that has pH of 14, they are very, very basic. They are very, very basic compared to substance that have pH of 8, okay, which are less basic. So increase as alkalinity increase in this direction. Why increase acidity increase in this direction? Okay, so if you look at this, which one of this substance, because all of them have the same molar concentration, so which one of them have the lowest pH? If you look at this one, has 12. So it shows you that this substance is an alkaline, has high alkalinity. It means that this substance has high alkalinity. If you check the question, say which of the following compound is the most acidic? So this one is off. because where the pH is 12. If you look at this other one, 9.3, so it lies within here, 9.3, shows that the substance is what? Alkaline. And we are looking for what? The most acidic. So this one is out. Then if you check this, if you check this, the pH is 4.4. So that is the last here. Then if you check A, the pH is 4. 4. 4 and 4.4, which one has high acidity is what? Is 4. So the answer is what? Is A. Okay? Yes. So we move to question 10, which is which is the strongest acid among the series of acid formed by chlorine? So let me give you guys a simple way to just know without stressing yourself. The acid formed by chlorine and the one that have high number of oxygen. The one that have high number of oxygen is the most acidic. Okay, so out of this acid, the one that have high number of oxygen is the most acidic. If you look at here, number of oxygen is 1. If you look at the number of oxygen is 3. If you look at here, number of oxygen is 2. If you look at here, number of oxygen is 4. So therefore, this is the strongest acidic. This is the strongest acid in this series of acid formed by chlorine. Okay, the one that has large number of oxygen. Okay. Now move to the next question, question 11. Which of the following can be Lewis acid? So the answer is boron trifluoride. Okay. Lewis acid. Remember, Lewis acid, they do what? They accept, they are electron pair acceptor. They usually accept lone pair of electron. Okay. Yes. So boron trifluoride is a Lewis acid. Then now this part is calculation. Okay. Now let's do it. They said, then before we do question 12, let's do question 13. They said, which is an acidic oxide? Remember, acidic oxide, they're usually oxide of non-metal. Yes, they're usually oxide of non-metal. While basic oxide are oxide of metals, right? Yes, so if you check here, which of these oxide contains a non-metal? This one contains a metal, so this one is out. This one contains a metal, this is rubidium, this one is out. This one contains metal, so this one is out. This one contains non-metal, so this is the acidic oxide. There is selenium, and selenium is a non-metal. So the answer is selenium oxide. So which is an acidic oxide, okay? Yes. Then move back to question 12. They said, what weight of anhydrous sodium trioxocarbonate 4 is required to prepare 0.05 molar solution of each solution in 250 ml. So this one is still coming from what? Molarity. So that's the that the most questions usually comes out in molarity regarding CHM107. Okay. Now what is formula for molarity? Molarity is equals to what? The number of moles of the solute divided by the volume of the solution in what? In liter. Okay. Yes. In this question, our molarity is what? Our molarity is 0.05. Right? Then our number of moles we don't know. The volume is what? 250 ml. Remember, our volume of water must always be in liter. So we convert 250 ml to liter by dividing 250 by what? 1000. So if we divide 250 by 1000, 250 divided 1000, we have what? 0.25, right? Yes, 0.25. What are we looking for? We're looking for what? The weight, which is the mass in gram, right? Yes. In order to get the mass in gram, we need to first look for the mole first, okay? So if we cross multiply 0.25, if we cross multiplying 0.05, we have 0.0125. So number of moles was 0.0125. Are we done yet? No, we are looking for what? They say what weight or the mass, okay? So we all know that number of moles is equals to what? Mass in gram, right? Divided by what? Molar mass. So the number of moles is 0.0125. Then the mass in gram, which we are looking for, divided by. Now, what is the molar mass of this molar mass? So what is the molar mass of sodium trioxocarbonate 4? It's very easy. So this is sodium trioxocarbonate 4, right? Yes, so this is the formula. Okay, so let's continue. Now, sodium, the molar mass of sodium is what? 23. Remember, they are what? There are 2 sodium, so times 2, bracket close, then plus molar mass of carbon is 12, then plus molar mass of oxygen is 16. Remember, there are 3 oxygen, so times 3. So if we add everything, we get 106, if I'm not mistaken. So 23, let me do it, bracket open, 23 times 2, bracket close, plus 12, then plus bracket open, 16 times 3. bracket close. Yeah, 106. So molar mass of sodium transcarbonate 4 is 106. So if we cross multiply, so 106 times 0.0125 will give us the mass in gram or the weight of sodium transcarbonate 4, which is what? Which is 1.325 gram. So 1.325 gram, which is D, is the answer. Okay, so and let's move to the next question, which is question. Yeah, we did question 13, question 14. So the next question is question 15. Let's continue with question 15 to question 21. So let's do question 21 first. In order to conserve space for question 15, they said, which of the following solution is the strongest oxidizing agent? A. Permanganate ion in acid, permanganate ion in base. Okay. Manganate ion in base, chromate ion in acid, chromate ion. Okay, I think this one is supposed to be chromate ion in base or so. Okay, base. Okay, one is acid, the other one is base. Okay, so the rightful answer is permanganate ion in acid is the strongest oxidizing agent. Okay, let's see which of the solution is the strongest oxidizing agent. The answer is permanganate ion in acid. Okay. So let's do the next question, which is question 15. I said, what is the molar concentration? So that is molarity, right? Yes, molarity is the number of mole of the solute divided by the volume in liter. Okay. I said, what is the molar concentration in mole per liter of a standard solution prepared by dissolving 10.6 gram of sodium tricarbonate 4 in 1 liter of water? So it's very easy. Okay, we are looking for what? The molarity. They give us. Now let's look for the mole first. Number of moles is equals to mass in gram over molar mass, right? Now the mass of sodium. Now the mass in gram of sodium tricarbonate 4 is what? 10.6. Okay. Then whenever the molar mass of sodium tricarbonate 4 is 106. Sodium tricarbonate 4 is very easy. The mass of sodium is 23. Remember, there are 2, so times 2, bracket open, bracket close, plus the mass of calcium is 12. I mean, the mass of carbon is 12, then plus the mass of oxygen is 16 times 3. If you add everything, you have 106. Okay, so this is the molar mass of sodium tricarbonate 4. So the molar mass is what? 106. So if we divide everything, 10.6 divide 106 give us 0.1. Therefore, the mole of sodium tricarbonate 4 is 0.1. Now, what about the volume? The volume is what? They say the volume of the solution, right? So the volume is 1, right? Yes. Volume, they said in 1 liter of water. So the volume is what? Is 1 liter, right? So if you divide it, you still have 0.1 molar concentration. So the answer is C, right? Can be M, a molar concentration, or mole per liter, which is same as what? M. Okay, so the answer is 0.1, which is C. Okay. Now move to the next question, which is question 16. Which of the following is the strongest brusted acid, brucellaric acid? Which of the following is the strongest brucellaric acid? Remember, sodium hydroxide is not an acid, so this one is out. This one is not an acid, so this one is out. This one is a very weak acid, so this one is out. This one is still weak, so this one is out. So the answer is what? Ozonium ion or hydrozonium ion. So which is A. Now, which of the following is the strongest brucellaric base? So, okay, the answer is oxygen diion, something like that. So oxygen carrying 2 negatives. So this is the strongest brucellaric base. Now, if you look at this other one, which of the following is the weakest brucellaric acid? So remember, this one is that. Okay, this is aluminum hydroxide, which is amphoteric, but mainly is mainly a base. So is out. Then they say weakest brucellaric acid. Which of these is the weakest brucellaric acid? Remember, H2SO4 is a strong acid, right? Yes. This one is a strong acid. This one is a strong acid. Therefore, the answer is what? Is carbonic acid. carbonic acid is very weak, H2CO3. So the answer is C, carbonic acid. All listed compounds are strong acid except carbonic. Still, if you look at this one is a strong acid. This one is that. This one is a strong acid. This one is that. This one is a strong acid. This one is the answer, carbonic. Carbonic acid is a weak acid. Now look at question 20. All the properties listed are required of a primary standard. Remember, so you guys, primary standard, they are not hygroscopic. They have the definite composition. They are stable at room temperature. They are pure, possess definite composition, stable at room temperature, and they are not hygroscopic. Never, they are not hygroscopic. So the answer is, well, they say all the properties listed are required of a primary standard except. So remember, primary standard, they are not hygroscopic. Okay, so the answer is D. Okay, so these ones are the properties: highly pure, possess definite composition, stable at room temperature. Hygroscopic? No, they are not hygroscopic. So the answer is D. Okay, now let's move to the next question. That is question 22. Question 22 to question 27. Okay, so question 22. If you look at this one, you find out that this ion dissociating to this one plus chloride ion. Okay, they said this type of reaction is I'm coming. Is an example of what? This type of reaction. This type of reaction is an example of what? So this type of reaction is an example of a disproportionation, or a disproportional reaction. Okay, so this type of reaction is known as a disproportional reaction. A disproportional reaction is a reaction whereby one substance behaves as an oxidizing agent as well as an oxidizing agent and a reducing agent. Okay, so this type of reaction is known as a disproportional reaction. Okay, then for the next question, which is question 23. The next question, which is question 23, they said a solution is prepared by mixing 1 gram of ethanol with 100 gram of water. Calculate the mass percent of ethanol in this solution. Now, to calculate mass percent is very easy. Remember, a solution is made up of what? Solution is made up of the solvent. The solute plus the solvent, right? Yes. Now, the solute here is what? Is ethanol, right? Ethanol is what? Ethanol is the solute. Then remember, the solvent is what? Is water. So a solution is prepared by mixing 1 gram of ethanol, which is the solute, with 100 gram of water, which is the solvent. They said calculate the mass percent of ethanol. It's very easy. To calculate mass percent equals to mass of solute. Equals to mass of solute divided by mass of solution. Mass of solution. Then times 100. Okay, then times 100. Okay. So what is the mass of the solute? The mass of ethanol, which is the solute, is what? Is just 1 gram, right? So 1 gram. Then divided by the mass of the solution. Remember, solution is made up of solute and solvent, right? The solute is ethanol, right? And okay, yes, the solute is ethanol, right? So what is the mass of ethanol? 1 gram, right? Plus, remember, mass of the solution. Solution is made up of solute and solvent. The mass of the solute is 1 gram. What about the solvent? The mass of the solvent is what? Is 100 gram, right? So we have something like this. Okay, so 1 plus 100 give us what? 101. So this is the mass of the solution. Okay, the mass of the solution is 101. The mass of the solute is 1, right? Yes. Then times 100. So if we do everything, 1 times 100 give us 100. Then 100 divided 1 will give us what? So 100 divided 1 will give us 0.99%. So the answer is B. Okay, so that is how you calculate this. The mass of the solute then divided by the mass of the solution. Remember, solution is made up of the solute and the solvent. So you add the mass of the solute plus the mass of the solvent to get the mass of the solution. Then this is the mass of the solvent, this is the mass of solution, divide them, then times it with 100. So you get you get your mass percent. So the answer is 0.99%. Then we move to 24. A standard solution is just known that a standard solution is a solution that has a known concentration. Solution that has a known concentration. Okay, a known concentration is a standard solution. Okay, then 25. A standard sodium hydroxide solution cannot be made by weighing accurately a given mass of the solid and making it up to the required volume of solution, because why? They said, okay, a standard sodium hydroxide solution cannot be made by weighing accurately a given mass of the solid. Yes, and making it up to the required volume of the solution, because it is what? Okay, sodium hydroxide, normally the solid, if you expose it normally, it will absorb water, right? To absorb water. So you cannot measure look at it, they said, okay, cannot be made by weighing accurately a given mass of the solid and making it up to the required volume of solution, because why? It will absorb water. Because sodium hydroxide is what? The liquid scent, right? Yes, the liquid scent, it absorb water. So the answer is C. Sodium hydroxide solid is the liquid scent. Then question 26. Which of the following is not a way by which a solid solute can be made to dissolve quickly in a liquid solvent? So now, which of the way in which which of the following is not a way by which a solid can be made to dissolve quickly? Okay, normally to make a solid dissolve quickly in a liquid, but you stir the solid vigorously, you heat the solid, grind the solid into powdery form. Yes, you grind the solid into powdery form, the solid will dissolve quickly. If you stir it, the solid will dissolve quickly. If you heat it and shake, the solid will dissolve quickly. Then if you even pulverize it, it will also dissolve quickly. So they say, which of these is not a way by which a solid can be made to dissolve quickly? So all of these are the ways. Yes, by stirring, by heating, by grinding, by pulverizing. So the answer is none. Okay, which is E. Then let's do the last question. They said, what volume of, okay, so let me clean this part so that we can solve it. Okay, so let me see. So I said, what volume of 0.25 molar solution of HNO3 reacts with 44.8 ml of 0.150 molar concentration of sodium transcarbonate 4 in the following reaction? So this is the reaction. 2 HNO3 reacted with sodium transcarbonate 4 to give 2 sodium transnitrate 5 salt plus carbon 4 oxide plus water. Okay, they're asking us to look for what? The volume of the acid, which is very easy. Okay, so something like this, we use carbon and bar. Ca multiplied by V is equals to Na divided by Cb multiplied by Vb equals to Nb. Okay, equals to Nb. Okay, Ca is what? Concentration of the acid. Okay, while this one is what? Volume of the acid. Volume of acid. This one is mole of acid. This one is mole of base. Mole of base. Okay, this one is volume of base. Volume of base. While this one is what? Concentration or molarity of what? Of base. So it's very easy. What is the concentration of the acid? 0.25, right? So 0.25 then times, we are looking for what? They said what volume of 0.250, okay, 0.25, okay. So what volume of 0.25 molar concentration of HNO3? So we are looking for the volume, which is VA, we don't know. Then equals to the mole of the acid. Now the mole of the acid from the balance equation, how many mole does the acid have? Is 2. So put 2 here. Okay. Then what is concentration on the base? Concentration on the base is 0.150 molar concentration of sodium transcarbonate first. So this is the concentration on the base, which is 0.150. Then times the volume of the base is 44.8. Okay, 44.8. Then equals to, now what about the number of mole of the base? Number of mole of the base is, there is just 1, right? So 1. We are looking for the volume of the acid. So if we cross multiply, so we'll now see like this: 0.250 times volume of the acid times 1, then equals to what? 2 times 1. Okay, let me just do it here. Okay, so we have something like this: 0.250 times volume of the acid times 1, then equals to what? 2 times 0.150 times what? 44.8. We are looking for the volume of the acid, right? So everything here, if they multiply, we have 0.250 volume volume of the acid, right? Times 1 will give us everything. Then equals to, if we multiply this one, we do it 2 times 0.150, then times 44.8. If we do it, we have 13.44. So 13.44. Okay. Then what I'm going to do next, we're looking for the volume of the acid. So divide both sides by 0.250. 0.250. So I'll cancel this. So 13.44. 13.44 divide 0.250 will give us what? Will give us 53.76. 53.76 mil. Okay, since our answer is usually 53.76. So approximately what? Approximately 53 points. What am I saying? 53.76, right? Which is approximately what? 8. Right? We have 53.76. If you approximate it, now we got 53.8 mil, right? Yes. Since the answer in the option is in mil, we leave our answer in mil. We don't need to convert again, because why? In the option, the answer is what? Is in mil. So the answer is 53.8 mil.